Ground fault circuit interrupter, or GFCI, protection is indeed required for receptacles located within the work area of a body shop. This requirement is put in place to enhance electrical safety and mitigate the risk of electrical shock to personnel working in an environment where the likelihood of contact with conductive materials and wet surfaces is higher. In a body shop setting, various electrical tools and equipment are routinely used, increasing the potential for ground faults. A ground fault occurs when there is an unintended electrical path from a hot conductor to ground. This can happen due to damaged insulation, faulty equipment, or accidental contact with a grounded surface. When a ground fault occurs, current can flow through a person who comes into contact with the faulty equipment or the ground path, resulting in a potentially lethal electrical shock. Ground fault circuit interrupters are designed to detect even small imbalances in current flow between the hot and neutral conductors in a circuit. Normally, the current flowing through the hot conductor should return through the neutral conductor. If a ground fault occurs, some of the current will divert to ground, creating an imbalance. When a GFCI detects this imbalance, typically a current difference of 5 mA or less, it quickly trips the circuit, interrupting the flow of electricity and preventing a dangerous electrical shock. The National Electrical Code, or NEC, provides detailed guidelines and requirements for electrical installations, including the use of GFCIs in specific locations. While the exact wording and specific applications may vary depending on the addition of the NEC and local amendments, the general principle of requiring GFCI protection in areas where electrical hazards are elevated remains consistent. Typically, the NEC mandates GFCI protection for receptacles located in damp or wet locations such as bathrooms, kitchens, and outdoor areas. In the context of a body shop, the work area is often considered a location where the potential for contact with water, conductive materials, and grounded surfaces is high. Therefore, GFCI protection is generally required for receptacles in this area. It is important to consult the specific edition of the NEC adopted by the local jurisdiction to determine the precise requirements for GFCI protection in body shops. Local amendments or interpretations may also apply, so it is crucial to verify the specific regulations with the local electrical inspector or authority having jurisdiction. In addition to the NEC, other relevant standards and regulations may also apply to electrical installations in body shops. For example, the Occupational Safety and Health Administration, or OSHA, has regulations that address electrical safety in the workplace. These regulations may include requirements for GFCI protection, as well as other measures to prevent electrical hazards. When installing GFCI protection in a body shop, it is essential to follow the manufacturer's instructions and all applicable electrical codes and standards. GFCI should be installed by qualified electricians who are familiar with the NEC and local requirements. The proper installation and testing of GFCIs are critical to ensure their effectiveness in preventing electrical shocks. There are two main types of GFCIs available for use in receptacle circuits: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard receptacles and provide GFCI protection only for that specific receptacle and any downstream receptacles that are wired to it. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection for the entire circuit. The choice between receptacle type and circuit breaker type GFCIs depends on the specific application and the desired level of protection. In some cases, it may be necessary to use a combination of both types to achieve comprehensive GFCI protection. Regularly testing GFCIs is crucial to ensure that they are functioning properly. GFCIs should be tested at least once a month by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCI protection, other safety measures should be implemented in body shops to minimize the risk of electrical hazards. These measures may include the use of properly grounded equipment, regular inspection of electrical cords and equipment, and the provision of appropriate personal protective equipment, such as rubber gloves and insulated footwear. Furthermore, it is essential to train employees on electrical safety procedures and the proper use of electrical equipment. Employees should be aware of the potential hazards associated with electricity and how to prevent electrical shocks. Training should cover topics such as ground fault protection, proper grounding techniques, and the importance of using GFCI protected circuits. Regular safety audits and inspections should be conducted to identify and address any potential electrical hazards in the body shop. These audits should include a review of electrical installations, equipment, and work practices. Any identified hazards should be promptly corrected to prevent accidents and injuries. It is also important to maintain accurate records of electrical inspections, testing, and repairs. These records can be used to track the condition of electrical equipment and to identify any recurring problems. Proper record keeping can also help to demonstrate compliance with applicable codes and regulations. In summary, GFCI protection is generally required for receptacles in the work area of a body shop to enhance electrical safety and prevent electrical shocks. The specific requirements for GFCI protection may vary depending on the addition of the NEC adopted by the local jurisdiction and any local amendments or interpretations. It is essential to consult with a qualified electrician and the local electrical inspector to ensure compliance with all applicable codes and regulations. In addition to GFCI protection, other safety measures should be implemented to minimize the risk of electrical hazards in body shops. These measures may include the use of properly grounded equipment, regular inspection of electrical cords and equipment, the provision of appropriate personal protective equipment, and employee training on electrical safety procedures. Regular safety audits and inspections should be conducted to identify and address any potential electrical hazards. Proper record keeping is also essential to track the condition of electrical equipment and to demonstrate compliance with applicable codes and regulations. Ground fault circuit interrupters are a critical safety device that can help to prevent electrical shocks in body shops and other environments where electrical hazards are elevated. By understanding the principles of ground fault protection and following all applicable codes and regulations, body shop owners and operators can create a safer work environment for their employees. Furthermore, consider these additional points. Firstly, ensure all electrical equipment used in the body shop is properly grounded according to the National Electrical Code requirements. Grounding provides a low impedance path for fault current to return to the source, helping to trip over current protective devices like circuit breakers, and further reduce the risk of electric shock. Secondly, implement a regular inspection and maintenance program for all electrical cords, plugs, and equipment. Look for signs of damage such as frayed cords, cracked insulation, and loose connections. Damaged equipment should be repaired or replaced immediately. Thirdly, train employees on the proper use of electrical equipment and the importance of reporting any electrical hazards. Training should include information on how to identify potential hazards, how to use equipment safely, and what to do in the event of an electrical incident. Fourthly, provide employees with appropriate personal protective equipment such as rubber gloves, insulative footwear, and safety glasses. This equipment can help to protect employees from electrical shock and other hazards. Fifthly, consider using portable ground fault circuit interrupters for temporary electrical connections or when working with portable equipment. These devices provide an additional layer of protection and can be easily moved from one location to another. Sixthly, ensure that all electrical panels and equipment are properly labeled and accessible. This will help to facilitate maintenance and repairs, and also make it easier for emergency responders to locate and shut off power in the event of an incident. Seventhly, maintain a safe distance from overhead power lines when working outdoors. Overhead power lines can pose a significant electrical hazard, and it is important to stay at least 10 feet away from them at all times. Eighthly, use non-conductive ladders and tools when working near electrical equipment. Metal ladders and tools can conduct electricity and pose a serious shock hazard. Ninthly, never work on electrical equipment while standing in water or on a wet surface. Water is an excellent conductor of electricity, and standing in water significantly increases the risk of electric shock. Tenthly, always energize electrical equipment before performing any maintenance or repairs. This can be accomplished by turning off the circuit breaker or disconnecting the equipment from the power source. Verify that the equipment is de-energized using a voltage tester before beginning work. By following these additional safety measures, body shop owners and operators can further reduce the risk of electrical hazards and create a safer work environment for their employees. It is important to remember that electrical safety is an ongoing process and requires continuous vigilance and attention to detail. Moreover, never bypass or disable any safety devices such as ground fault circuit interrupters or overcurrent protective devices. These devices are designed to protect people from electrical shock and prevent fires. Tampering with these devices can create a serious safety hazard. When working with electrical equipment, always follow the manufacturer's instructions and recommendations. This will help to ensure that the equipment is used safely and effectively. If you are unsure about any aspect of electrical safety, consult with a qualified electrician or electrical safety professional. These experts can provide guidance and assistance to help you create a safe electrical work environment. Be aware of the presence of any underground utilities before digging or excavating. Contact the local utility companies to locate any underground cables or pipelines and avoid damaging them. Damaging underground utilities can create a serious safety hazard and disrupt service to the surrounding area. Establish an emergency action plan in case of an electrical incident. The plan should include procedures for reporting the incident, evacuating the area, and providing first aid to any injured personnel. Practice the emergency action plan regularly to ensure that everyone knows what to do in the event of an emergency. Periodically review and update the electrical safety program to ensure that it remains effective and up to date. Changes in technology, regulations, and work practices may require modifications to the program. Keeping the electrical safety program current will help to maintain a safe work environment and prevent accidents. All personnel should be empowered to report any electrical hazards or unsafe conditions without fear of reprisal. Encourage open communication and create a culture of safety where everyone is responsible for identifying and addressing potential hazards. Promote a proactive approach to electrical safety by identifying and addressing potential hazards before they cause accidents or injuries. This can be accomplished through regular safety audits, inspections, and hazard assessments. Invest in electrical safety training for all employees. The training should be tailored to the specific hazards and risks associated with their jobs. Effective training can help employees to recognize and avoid electrical hazards, and also teach them how to respond appropriately in the event of an electrical incident. Make sure that all electrical work is performed by qualified and licensed electricians. This will ensure that the work is done safely and in compliance with all applicable codes and regulations. Using unqualified or unlicensed personnel to perform electrical work can create a serious safety hazard and may also violate local laws. Avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. Overloading circuits can cause overheating and increase the risk of fire. Use power strips with built-in circuit breakers to protect against overloading. Be especially careful when working with electricity in damp or wet environments. The risk of electric shock is significantly higher in these conditions. Use ground fault circuit interrupters and take extra precautions to avoid contact with water. Develop a comprehensive electrical safety program that includes all of the elements discussed above. The program should be written, implemented, and enforced consistently throughout the organization. A well-designed and implemented electrical safety program can help to create a safer work environment and prevent accidents and injuries. When selecting electrical equipment, choose products that are listed or certified by a recognized testing laboratory such as Underwriters Laboratories, or Canadian Standards Association, or CSA. These products have been tested and found to meet accepted safety standards. Using listed or certified equipment can help to reduce the risk of electrical hazards. Be careful when using extension cords. Extension cords should only be used for temporary applications and should not be used as a substitute for permanent wiring. Choose extension cords that are the appropriate size and gauge for the intended use and avoid overloading them. Inspect extension cords regularly for damage and replace them if they are frayed, cracked, or otherwise damaged. Store flammable materials away from electrical equipment and wiring. Flammable materials can ignite if they come into contact with hot electrical components. Keep flammable materials in approved containers and store them in a well-ventilated area away from electrical hazards. Develop a lockout/tagout procedure for energizing electrical equipment before performing maintenance or repairs. The lockout/tagout procedure should be written, implemented, and enforced consistently. The procedure should include steps for identifying and isolating the energy source, applying lockout devices to prevent equipment from being energized, and verifying that the equipment is de-energized before beginning work. Consider using arc flash protection when working on or near energized electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns, injuries, and even death. Arc flash protection includes the use of personal protective equipment, such as arc-rated clothing and face shields, and the implementation of safe work practices to minimize the risk of arc flash. Conduct regular safety meetings to discuss electrical safety issues and reinforce safe work practices. Safety meetings provide an opportunity to share information, address concerns, and promote a culture of safety. Involve employees in the development and implementation of the electrical safety program. Employees are often the best source of information about potential hazards and can provide valuable insights into how to improve safety. Create a system for tracking and investigating electrical incidents. All electrical incidents, no matter how minor, should be reported and investigated to determine the root cause and prevent similar incidents from occurring in the future. Promote a culture of continuous improvement in electrical safety. Regularly review and evaluate the electrical safety program to identify areas for improvement and implement changes to enhance safety. Encourage employees to suggest ways to improve electrical safety and recognize them for their contributions. Stay up to date on the latest electrical safety codes, standards, and regulations. Electrical codes and regulations are constantly evolving, so it is important to stay informed of the latest changes and ensure that your electrical safety program is in compliance. Attend electrical safety training courses and conferences to stay abreast of the latest developments in the field. Share electrical safety information with others in the industry. By sharing information and best practices, you can help to improve electrical safety across the board. Work with industry associations and organizations to promote electrical safety awareness and education. By working together, we can create a safer work environment for everyone. Be a role model for electrical safety. Set a good example by following all electrical safety rules and procedures and encouraging others to do the same. Show that you are committed to electrical safety by participating in safety meetings, wearing appropriate personal protective equipment, and reporting any electrical hazards that you observe. Make electrical safety a top priority in your organization. By making electrical safety a priority, you can create a culture of safety where everyone is aware of the risks and committed to preventing accidents and injuries. Remember that electrical safety is everyone's responsibility. By working together, we can create a safer work environment for ourselves and for others.